The following podcast is a proud member of the Blue Collar Roots Network. Find all the shows by visiting bluecollarroots.com. He may seem like a mild-mannered engineer until you install an HVAC system improperly. Then the whole turning green Hulk shirt-ripping thing happens, and it's not pretty. Here's Bill Spohn.
Welcome back to another episode of the Building HVAC Science Podcast, where it's our goal to try to relate all the scientific topics that are going on in the world of building science and HVAC. We're trying to help these two professions work better together and understand each other. And our ultimate goal is customer service, making customers happy, the homes they live in, the buildings they worked in. I get a chance to meet a lot of interesting people as I go through the walks of my daily life here at TruTech Tools. And one of the interesting people I met recently, so it's actually a couple years ago, was Steve Rogers. He's our guest today. He's the president and owner of the Energy Conservatory, and he's going to talk about these two important questions. One is, why would I want to use an AirFlow hood? Now, you might think you know an answer to that, and you probably do. The second question is, you might not know the answer to this one. How do I find a good AirFlow hood? So let's listen in as Steve talks about this topic, talks about the Energy Conservatory, his career. I think it's a very interesting discussion that you'll want to listen to. If you happen to listen to this podcast before January 24th, 2019, you can sign up to watch a webinar that Steve's going to present with TruTech Tools. And if you watch it live and you need BPI CEUs and you sign up, you'll be able to get CEUs for it. The webinar link to sign up is bit.ly/TechFlow. And I'll spell that out, www.bit.ly/TEC, uppercase, -FLOW, all uppercase. So it's bit.ly/tech-flow. Now, if you listen to this afterwards, we're going to have a recording of this video of the webinar that he does on the TruTech YouTube channel. So listen up as Steve talks about AirFlow hoods and milkshakes. Interesting, huh? All the way from Minnesota. How you doing, Steve?
Pretty good. Good to be here, Bill.
Good. Glad to hear that. So our topic sentence today, our discussion point, is why would I want to use a flow hood, and sort of the subtopic, and how do I find a good one? Because that's always important. Why don't we get into the why of using a flow hood? From your perspective, why would someone want to use a flow hood?
The best answer to that question is something that we sort of stumbled on about a year and a half ago. We did a ride along with one of our customers, just watching how they do an energy audit of a house. And because we wanted to do the ride along with them and not impose on somebody, I asked a friend of mine if we could do it on their house since they had never had an energy audit. And as these things kind of go, they said, yeah, we'd love to have you do that. And by the way, we have this comfort problem. Our master bedroom is always really cold in the wintertime and it's too warm in the summertime. Do you know anything about that? And of course, I said, yeah, we have some equipment. We could make some measurements to see if we can figure out what's going on there. So really, that's the answer, is comfort problems. That's why you'd want to do a residential air balance.
It's really great that your company interacts with your customers in such an intimate way. I mean, that's really where I think great products, great ideas come from, and great companies are built upon. So kudos on doing that. So why don't you tell us a little bit about your company itself, the Energy Conservatory? When was it founded? Who founded it? Just kind of give us a nice overview of the company.
Yeah, the company was founded in about 1984 by Gary Nelson. And he was at the time really interested in energy efficiency of buildings. And he was aware of this thing called a blower door and wanted to understand how they worked better. But at the time, a blower door was an all-day project and a huge investment in equipment to be able to do it. And so Gary's contribution really was to be able to make it so you could do a blower door test in a matter of really just a few minutes and buy the equipment at a much more reasonable cost.
So I imagine that came through a lot of product evolution, things like that. Do you folks at the Energy Conservatory have any of the older models there? I mean, something to look at and like a relic you would look at and shake your head and go, wow, we used to do that?
Yeah, it's really interesting to see that old equipment. The frame, if you've seen a modern blower door, it's got an extruded aluminum frame and it's an injection molded fan housing. But the original ones, the frame that goes in the doorway was made out of plywood, and the fan was made from a fiberglass mold. and their fan housing, that is. There's really been quite an evolution. And the original manometer was magnehelic pressure gauges made by Dwyer. So it's been really quite an evolution since the original equipment.
Now you get basically complete kits,
Yep.
more or less plug and play with them. Of course, you need some training and background. So you mentioned Dwyer. You were talking about the Energy Conservatory. That kind of leads me to ask about your background, your personal background, Steve.
Yeah, so I'm fairly new to the energy efficiency and even the HVAC industry. I began working for the Energy Conservatory in 2015 after having relocated from Minneapolis to work for Dwyer Instruments. I had a great job there, spent just a year working for them. I liked the job, but it didn't work out for my family, so we wanted to relocate back to Minneapolis and came looking for a job and found this little company in Minneapolis that turned out to be a great fit for my skills and background, because what I had done for 20 years previously, or almost 20 years previously, is pressure and flow measurements in the industrial process control realm for a company called Emerson. If you're familiar with Emerson, that makes HVAC equipment, it's the same company, but a completely different division that makes industrial process controls.
Yeah, so things like Copeland compressors and the Comfort Guard system and things like that, and tons of controls and aftermarket products. And I think Emerson bought Cooper Atkins, which is a temperature data logging company last year. So they're all over the place. That's pretty cool.
Those divisions I was really not even aware of or ever worked with. I worked for the divisions of Emerson that are Rosemount. Some people have heard of Fisher control valves out of Marshalltown, Iowa. Rosemount pressure transmitters. It's all stuff that you'd find in a paper mill or a power plant.
So you started with TEC, Energy Conservatory, TEC, in 2015. And then how has your role evolved in the last few years?
Well, I began as the engineering and production manager. They were looking to do some reconfiguring of the company. And it came to my attention that within the first year that Gary was looking to sell the company. And he wanted some very specific things out of that transaction, and felt like I was the guy that could provide what he wanted out of the future of the company. And so in the fall of 2017, Gary sold the company to me. Gary remains very involved in the company. He comes to work every day. And so it's been great for that, have that continuity with Gary still involved in the company.
Sure. So much like myself, being a person with technical background, having worked for companies and then becoming an owner of a company, I'm sure that's been an interesting transformation in you personally, now being an entrepreneur and a business owner, huh?
Yeah, it's been interesting for me, but really a very comfortable fit, much more so than I would have ever expected. I love the challenge of having something kind of different and unrelated go on each day, from the people management to the technology to working with suppliers. It's stuff I've all done a little bit at a larger company. And I've always considered that one of the things I was good at is putting all the pieces together into a big picture. And so this is the ultimate opportunity to do that as a president of a company.
Cool. I know the Energy Conservatory does have training sessions for train the trainer and things like that. You do that fairly often?
Yeah, the Train the Trainer we've been doing once a year each summer, and we've had a really good turnout for that. So I should mention that over the years began with just the blower door. That was the only product. And from there, we moved into duct leakage. And from there, it moved into airflow measurements. People needed to measure, well, how much air is going through my exhaust fan and things like that. So I would really say that Energy Conservatory's core competencies today are low pressure measurements and airflow measurements. And I think that's what we really bring to the HVAC industry. And of course, a flow hood is a perfect fit for those measurements.
Absolutely. The low pressure and flow measurement. And I know, but you could explain to sort of our listeners, give them an idea. There's a lot of science that goes on in the development of these products, a lot of testing, math equations, fixtures, jigs, calibrations. Do you want to give us sort of an overview of, not in too much detail, but how do you go about developing a product or refining a product?
Well, we like to begin with what we call, if you're familiar with kind of technology and innovation, you may have run across this idea of understanding the job to be done. And there's a Harvard Business School professor that gives a really interesting talk about this, and McDonald's milkshakes of all things. And he talks about how McDonald's wanted to increase the sales of their milkshakes, and they changed different things and it wouldn't affect sales, and they'd change something else and it wouldn't affect sales, and they'd have focus groups and it never affected sales until they looked at it from the standpoint of, well, why do people buy milkshakes? What job, in quotes, are they trying to do with that milkshake? And they found out that like half their milkshake sales are made at before 8 o'clock in the morning, which is a real head scratcher, right? What they found is that people like a milkshake because it's a great thing to eat for breakfast on a long commute. And once they understood that was the job, in quotes, that somebody's trying to do, they were able to change the way that they formulate and market milkshakes, and their sales went up significantly. So we like to take that similar approach to understand what are people trying to accomplish. And that's where it all begins. And in the case of a flow hood, I think the job to be done there is to provide comfort in every room of the house. And if you don't know how much air is going to each room and what the loads ought to be or what the loads are, then it's really hard to get comfort in every room.
My familiarity with things like that are things like applications or use cases. I think those are all the similar terms for understanding the job to be done. The milkshake analogy, is that correct?
Yeah, they're similar, but not exactly the same. There's a quote, I can't remember who it's attributed to. And the quote is, people don't want half-inch drills. They want half-inch holes.
Right.
Okay. And so if you look at the parameters of the drill and that sort of thing, people don't care. What they want is a half-inch hole. And so it's a little bit different way of looking at the same thing.
Yeah, a lot of stepping back and reviewing that.
Yep.
Tell us what's going on with flow hoods. You've got some interesting tests and some studies that you've done and that grew out of this comfort problem at your friend's house.
Yeah. Energy Conservatory has had a flow hood for quite a while. And for anyone who's ever used the Energy Conservatory's flow hood called the Flow Blaster, they might know two things about it. Number one, it's really accurate. And number two, it's kind of cumbersome, honestly. It's heavier than most. It requires a battery pack. And we ended up actually canceling the product because of the difficulties we had with the battery pack. And it was just too difficult to re-engineer. So we've gone back to the drawing board, and eventually that product will be replaced with something newer and better.
That product, as I recall, was really an adaptation of the duct blaster hardware to a large extent?
Yes. It used the same fan and the same flow meter or flow measuring device as the duct blaster, which had benefits in that there's less equipment to buy, but the downside is that there's really way more fan there than you need.
Yeah, to do the job.
Yeah.
So can you tell us a little bit about some of the testing you've done in your research? Because you did present a paper on this back at the ASHRAE conference last January 18.
What we did is we bought flow hoods by 6 different manufacturers, and we've got a test rig that we've set up so that we can essentially simulate a scale down of a residential HVAC system. So it's a trunk with 4 branches, and that allows us to watch what happens to the flow, not only in the branch that you're measuring with the flow hood, but also what happens in the other 3 simultaneously. We're monitoring each of the 4 branches separately, as well as constantly measuring the flow that goes into the trunk and comes out the 4 branch registers. And that setup has been really useful in understanding that there's really 2 components to how well a flow hood works in terms of getting the right measurement. One is accuracy, that I think most people are familiar with. Most people are less familiar with the idea of insertion loss. And that turns out to be really, really important in flow hoods as well.
And you mentioned what else is happening in the other runs or branches of the duct. And sometimes when I do some teaching instruction on HVAC or airflow, I talk about air being squishy. Maybe there's a better scientific term for that. The system sort of reacts to the fact you're trying to measure it.
Yep. It's not just that it's squishy, that's part of it. But the other part of it is you can't really measure air without causing some sort of a restriction, even if it's a fairly minor restriction. And when you put a hood over a supply register, there's always some amount of restriction there. And some hoods have very little restriction and some have quite a bit. But if you restrict the flow in some degree, you're pushing less flow out the branch with the hood on it and a little bit more out all the others. That's what we refer to as insertion loss. And that's what you have to figure out a way to compensate for.
The thought that just popped in my head was a game of whack-a-mole. You're always trying to...
That's exactly the way it works. There's just too many other places for that air to escape. And because it's a very low pressure system, it will. I mean, if you put your hand over half the supply register in your living room, a little bit more air comes out all the other ones.
And I'm sure there's, going back to this understanding that jobs will be done, the milkshake analogy, you need to arrive at a good enough solution for the variables on hand at site. It can't be your lab, it could be a scientific solution, but for a product, it needs to be something that's usable and affordable. That goes back to some other things you're saying there.
Yeah, exactly. That's, I would say, a good lead into what we have in the industry. I think some hoods are really usable and the accuracy and the insertion loss might be questionable. Other products are really accurate, but the usability is not what it should be. And so we're looking to create a product that hits both.
In a fine enough fashion that it actually gets to be used. Because that sort of, going back to the comfort study that you did, how did that work out?
We started measuring the flows in each room of the house, and it became really clear. It's a 2-story house, colonial style, about 3,100 square feet. And it was fairly newer construction. It was built in the late 90s. So it's 2x6 construction, well-insulated walls. It's a fairly airtight house. But the family that lived there complained that the master suite was under conditioned. So it was too cold in the winter and too warm in the summer. And as we started going around with the flow hood from room to room, we immediately discovered that almost all the air in the whole system was coming out of 3 supply registers. There's 15 other registers in the house, and almost all of the others had flow that was nearly zero. So just to throw a couple numbers at you, the 3 supply registers measured in at 115, 114, and 144 CFM. And of the other dozen or so registers, none of them had more than 10. And, well, there's your problem. What we discovered was that somebody who had worked on the furnace, and we don't know how long it had been this way, had closed the main damper. The furnace was on one end of the house, and then there's, of course, the main trunk line that runs down the center of the house. And there was a damper between that main trunk line and the furnace box that was completely closed. So the 3 supply registers that were getting all the air were the 3 that branch off before that damper. And 2 of those went upstairs, fortunately, and 1 of them went downstairs, or they would have had one level that was almost completely unconditioned. But interestingly, even after we opened that damper, which clearly that was a mistake, that's not how the system was designed. So we opened that damper and then we made all the measurements again, because that's how the house was designed and that's how it was built. So as designed and as built, it was still not well distributed. All the flow was still getting, not all the flow, but nearly all the flow was still coming disproportionately to one end of the house versus the other. It was all coming to the end of the house where the furnace was, because it was in one end of the house and the far end of the house wasn't getting much air. So we set out to close the dampers that were getting too much air. And I think we really only had to adjust 3 or 4 of them. And once we did that, the house became pretty well distributed, both upstairs, downstairs, and from the end of the house that's near the air handler and the end of the house that's far away. So after we did that, what was really interesting is the follow-up I had with this friend of ours. And I said, you really shouldn't have to have that electric blanket in the master bedroom in the wintertime. And he told me at the time that we did the air balancing, I said, I don't think you're going to need that. He said, well, we kind of like it. And then he texted me a couple weeks later after we had some really cold winter nights in Minnesota. And he said, you're right. We turned on the electric blanket the other night and we turned it off 10 minutes later because it was too hot. So mission accomplished. They were comfortable without the electric blanket, which was the only way they could sleep comfortably in the master suite.
Did you ever do a building shell test on that, or a duct leakage test?
We didn't do a duct leakage because all the duct work is indoors. It was clear that some duct sealing had been done. There was mastic on the ducts.
Okay.
It measured it in at 2.4 ACH 50, which Minnesota code is 3. So it was better than code, even though it was built before the code came into place or came into force.
That's your blower door number, just for people listening that don't know the jargon here. That's a pretty tight house.
Yeah, exactly. And for context, in the southern states where climates are not as extreme, typically they will try to achieve 5 ACH 50, that's air changes per hour when measured at 50 pascals. And in the northern climates, most states have a requirement of 3 ACH 50 or less. You want fewer than 3 air changes per hour when measured at a pressure in the house of 50 pascals.
You went into this house sort of like a comfort consultant, aiming to solve a problem and do some things. And I'm sure you know of the ACA manuals, J, D, S, and R. Did you ever employ any of those, or was it more like you just have so many variables at hand, you can only fix so much, let's go measure and do something?
Well, we didn't need to. We're able to achieve comfort without doing a manual J. I would say the house was so far out of balance that it was obvious what the problem was. In the upstairs, we had a master bedroom, which was about twice the size of the bedroom. So in one end of the house is the master suite, and it was on the far end from the air handler. And on the other end of the house, and near the air handler, were 2 bedrooms. So as designed and built, each of those bedrooms was getting about 50 CFM, while the whole master suite, which is almost twice the size and has 3 exterior walls, was getting just over 40. And it doesn't take a manual J to tell you that's wrong.
We mentioned earlier that you did give this presentation at the ASHRAE conference, the TECnical conference, and you've agreed to do that with TruTech Tools through a webinar coming up. And for people listening now, the date of recording is January 4th, but this will be January 24th. So if you listen before that date, I'm going to give you a link right now that you can go to sign up for that webinar, to see the sketches, to see the illustrations, to see the testing that we're talking about here. That link is www.bit.ly, that's bit.ly/tech-flow. And that's all uppercase, TEC-FLOW. And that will take you to a registration form for the webinar, so you get to hear it live. But if you're listening to this after the webinar has been produced, we'll be putting it up on the TruTech YouTube channel. So if you just go into TruTech Tools on YouTube, you'll find a recording of this webinar. So there's a chance really to sort of dig into a lot of the technical and also get the visual aspect of what Steve's talking about here today.
Thanks, Bill.
You're welcome.
I do want to reiterate that the right way to do a balancing is to do a manual J and to find out what the loads are in each room and how much air is required, and then balance it accordingly. I think the only reason this family was comfortable at all with how poorly balanced the system was is because they had a pretty good shell on the house, 2x6 construction and pretty good air tightness. Had they not had that, I think it would have been unbearable.
Yeah, what about much worse?
Yeah, I mean, if you really want to achieve the best comfort, you should be doing a manual J when you're installing new equipment anyway. And once you've got those numbers, you should have room by room loads, and that'll tell you what your airflow should be in each register.
Back to talking about the Energy Conservatory, you have a great website that explains all your products. You have resources. You folks do webinars. I always look at some of your instruction manuals are almost like cookbooks on how the product works. I think it's really great that you share that level of detail, and I think that sort of indicates the scientific nature of the leadership there at Tech. So kudos on that.
Yeah, you mentioned the original blower door manual, or it's not the original, but it's not our most recent, but there's a blower door manual that's about 100 pages long.
Yeah.
And if you look at that, it's not really how to use our equipment. It's things like, why would I do a blower door test? How should I prepare the house for a blower door test? And things like that are just general knowledge. And the reason that was done is because at the time, people didn't even know the answers to those basic questions.
Yeah, you really share information. That's a wonderful thing.
Yeah.
In addition to this webinar coming up and then the subsequent recording for anyone listening, where can they see your products or reach you? TruTech Tools, my company, carries your products. We're really proud to carry them. But you guys do a lot of trade shows out there, so you actually get in front of people. Where do those things take place?
Probably the 2 biggest trade shows we do are HPC, the Home Performance Coalition show, and the ResNet show. And I can't remember where ResNet is this year.
Yeah, ResNet's going to be in New Orleans, and I think it starts the 25th of February. And HPC, I want to say, is around April 1st in Chicago this coming year. This would be 2019.
Yep, that's right. But you'll find us at some smaller shows as well. We do some regional things in the weatherization industry. We have done some regional HVAC ACA shows. I could get a more complete list if we'd like to do that, but I don't know off the top of my head everything we do.
Yeah, and your website, I'm sure, has it. And you guys have a newsletter, which you can subscribe to from the website. So anyone interested What's the web address again? Is it the Energy Conservatory?
No, it's just energyconservatory.com.
Okay. That's an interesting name. Can you tell us the origin of that name? Just a little fun fact here.
Yeah, the fun fact here is that the company was founded by Gary Nelson, and at the time he had a partner named Gary Anderson. A couple good Scandinavian Minnesota names for you. But they were both interested in music. Gary Nelson has played trombone in a community band for many, many years, and Gary Anderson was also a musician. And so they thought about, conservatory of music as an analogy, that the Energy Conservatory was conceived as a place where you could not only buy the equipment to do the tools or to make the measurements, but also as a place to learn how to do it. And I think that that's part of our mission that's been carried forward ever since, that we don't just sell the equipment, we will teach you how to use it, why to use it, why would you want to use it.
That's a really great heritage to develop and to continue to execute on. So there's also a couple of fun videos out there on YouTube. Do you know the two I'm talking about?
Well, I think I know. The one is Tool Time is that one of the ones you're talking about?
Yep. Tool Time, the old TV show with Tim
Allen, yeah.
Tim Allen, yeah. And then also there's one with James Brown.
Yep.
Who was doing some community service work and explained a blower door. And then another one that involved the two original Garys roller skating to someone's aid to do a blower door call. Have you seen that one?
I have not seen that one. I need to see that one.
Ask Frank about that one. That's kind of fun. There's a little song. It's almost sort of like, I wouldn't call it a rap song because it was done in the 80s, but it was sort of like this nice little song that came up for that. So you guys obviously have fun there in addition to doing some excellent work. So really glad to have the chance to get you to come on the Building HVAC Science podcast and to talk to some people and to let them know you and your company in a little different way.
Yeah. Well, thanks very much, Bill.
You're welcome. Any closing thoughts, Steve?
I got a few more ideas just to talk about what to look for in a flow hood if you want to go there.
Yeah, let's do that.
We talked a little bit about what is accuracy and in more detail about what is insertion loss. It could be thought of as how much the thing you're trying to measure changes when you insert the measuring device. In this case, when I put a flow hood on a supply register, does it change the flow that I'm trying to measure in order for me to measure it? So what we found in our testing is that, not surprisingly, the flow hoods that are smaller in size create more restriction and more insertion loss. The very smallest one was showing insertion losses greater than 20% of the flow. So if you're measuring 50 CFM coming out of a supply register, it might knock it down to 40. Even though it might measure that 40 accurately, what you really wanted to know is how much flow is coming out before I put the hood on there, which was 50. So you're off by 20% right out of the box. Some of the larger flow hoods did a good job in terms of not creating insertion loss, but because they were so big compared to the size of the register, all the flow goes past the sensor and they just weren't accurate. They might have been 20 or even more than 20% off the flow measurement. So putting the flow hood on the same register that's giving 50 CFM, it might be over measuring by double. It might tell you that there's 100 CFM coming out of that register when there's only 50.
So it's a real balancing act, no pun intended, between size and restriction and size inability to measure these low pressures. That's what it sort of goes back to, is your description of what you guys exhibit your expertise in, is low pressure measurement, low flow.
Yeah.
Can you give us an idea, like scientifically, like what's the actual pressure in like a residential duct coming from a flow hood, say one of those 50 CFM supplies?
The pressure in the hood or in the trunk line?
Yeah, in the hood.
Yeah, in the hood, it's typically a couple of pascals.
Wow.
Very, very low pressure. And that's just that couple extra pascals of back pressure can reduce the flow significantly. And now with a really small one that creates a big insertion loss, it might be a lot more than it might be 10 pascals.
That's in under the hood.
Yeah, under the hood, that's the additional back pressure that's been created. But I did want to mention, so the question comes up, well, if I have a hood that might have a lot of insertion loss, but it's fairly accurate in most cases, is that good enough? Or conversely, if I get a hood that doesn't have much insertion loss, but it's not real accurate, could I just say, well, it's always going to measure 20% high, so I'll still get a balance? And the answer to both of those questions is no, it doesn't work. And the reason for that is if I get a hood that's off by 20%, it's not consistently 20% high or 20% low. In most cases, will depend on which way you put it on the register. And is the register on the left side or the right side or the top or the bottom? And in terms of insertion loss, you'd like to think, well, if my hood creates an insertion loss of 20%, well, isn't that just going to cause all my registers to be low by 20%? And the answer is no, because less flow means less insertion loss. Your highest flows are going to have the largest errors, and your lower flows are going to have less error. So you have to have a hood that has both good accuracy and low insertion loss.
The summary is there's really no blanket correction factor that can be applied with any kind of reliability.
Yes, exactly.
So for people who are thinking like, I know this and I know that, and I've done my own testing and I've cowboyed some testing here and there, and I think I'm just going to do that, you're really more or less fooling yourself.
Well, and you mentioned cowboying, that there's a very simple field test that you can do with any flow hood that'll give you some idea how good it is. And that is to simply move the hood around on the register, on any register, and see how much it changes. Because there's a pretty good correlation between how much the measurement changes when you move it around on the register and how accurate it is overall. So if you put the register in the upper right corner and then the lower left corner and in the center, how much does your measurement shift around? And if it's shifting around by 20%, then you know that you probably don't have a measurement that's better than 20%.
You're investing a lot of time here looking at these things. So and maybe it's too early to say, but you've got some ideas, can I say?
Yeah, we've been continuing to work on this problem, and I don't want to mention any dates or certain new products, but it's a problem that we're working on. It's not the only problem we're working on. There's
Sure.
several problems related to airflow measurements and pressures, of course, and the HVAC industry.
Fantastic. Does that sort of sum up your thoughts here for today?
Yeah, I think so.
Cool. Really appreciate you having you on. Again, I mentioned earlier the webinar coming up, which will then be recorded and available for use to look at the technical details of some of this work we're talking about here today in selecting and evaluating flow hoods. And then the trade shows that Steve mentioned that he attends, where you can get to meet him in person, or the smaller regional ones where you can meet reps of the company, things like that. Again, I want to thank you for coming on today. We've been meaning to do this for several months, and I'm glad we got to finally do this.
Yeah, it's been great. I appreciate you having me on, Bill.
Thank you. Appreciate it. Well, thank you for listening to this latest episode of the Building HVAC Science podcast, and hopefully you learned some things. Steve seems like a very thoughtful person. He is a very thoughtful person. And this aspect of conservatory, a place to learn, that really echoes really strongly with me. And that's what we try to do at my company, TruTech Tools. As a matter of fact, if you're interested in any of the products that Steve was talking about, you can get them at TruTech Tools. That's TruTechTools.com. And for many of the products, you can use a discount code of HVAC BS, that's HVAC Building Science, for a discount at TruTech Tools. Full disclosure, I'm one of the co-owners of TruTech. I want to thank you for listening, and I'd like you to consider following us on Facebook or subscribing to the podcast. That way you can get the fresh downloads all the time. If you're interested in becoming a sponsor or advertising on the podcast, that's also available. You can reach me through bill@bluecollarroots.com, which also makes me want to talk about the fact that I'm part of a network called the Blue Collar Roots Network. That's bluecollarroots.com. There's several other trade-oriented podcasts there, and we're doing our part to help transform and professionalize the trades by filling the skills gap through training and communication. And you can kind of get the idea from my communication that it's sort of all over the map, but that's like the way I am. Sometimes just ask people. I want to close today with a little quote that I think has an aspect of a relationship to what Steve was talking about today, and it sort of came in at the very beginning and was echoed throughout, and I really like that. This is a quote from Teddy Roosevelt. People do not care how much you know until they know how much you care. So I want to thank you for carefully listening to this podcast and hope to have you come back again and listen to more of the Building HVAC Science podcast. Take care, everyone.